I'm Alicia Stetin, EM Chief of Staff, and this is my first time attending this important gathering. I also want to thank ECA and FCOG for partnering with EM to put together such a strong event. It's great to meet so many who are critical to the progress we make at sites across the country. And it's great to meet representatives and residents from the communities near those sites that we are proud to support through cleanup. I am honored and privileged to have the opportunity to serve in President Trump's administration. This administration understands the role energy and innovation play in American security and prosperity. And this administration is driven to pursue real solutions to build a golden era of American energy dominance for the benefit of our nation. I'm still relatively new to EM. I'm only about 5 months into this role. But even so, I've gained a deep appreciation for what this program can do. Its record of safe and successful cleanup, and most importantly, how EM can help enable this golden era. My very first site visit was to Paducah, where we made the General Matter uranium enrichment announcement. I want to thank Joel and his team for being such gracious hosts. What I saw there was inspiring. EM's cleanup not only addresses legacy challenges, but also provides assets that advance DOE's broader mission, including the goal of unleashing the full potential of nuclear power. I also had the chance to join Secretary Wright at Savannah River National Laboratory for the opening of the Advanced Manufacturing Collaborative. That visit highlighted how EM isn't just solving problems of the past, but is enabling American innovation for the future. Edwin and Dr. Green, thank you for your hospitality and leadership. I'm excited to continue visiting more of our sites, including WIPP, which provides DOE's critical disposal capabilities, and West Valley in my home state of New York. At West Valley, I'm especially proud of the remarkable progress being made at the site with such a unique history, as the only commercial reprocessing facility ever to operate in the United States. Today, you'll hear directly from federal and industry leaders about some of these successes. DOE Savannah River Manager Edwin Deshong and SRNL Director Dr. Johnny Green will discuss the successful opening and launch of the AMC. Carlsbad Field Office Manager Mark Bollinger and Ken Harrawood, President and Program Manager for Salado Isolation Mining Contractors, will highlight the construction and commissioning of WIPP's new ventilation system. EM Consolidated Business Center Director Jack Zimmerman and Jason Casper, President and Program Manager for the West Valley Cleanup Alliance, will share the story of the safe demolition of the last major facility at West Valley, the main plant process building. I cannot be prouder of these accomplishments. They demonstrate not only technical excellence, but also the dedication of the people and partners who make progress possible. I hope each of you share that pride, because together we are writing the next chapter of EM, one that benefits not only the Department of Energy, but the entire nation. With that, it is my pleasure to turn things over to Edwin and Dr. Green to get us started. Thank you.
Good morning. I'm definitely excited to be here to really talk about AMC. And right now, we're really excited at Savannah River. We're celebrating our 75th anniversary of supporting the United States and our missions. And we're just doing a lot of great things there with our partners, SRMC, BSRA, and SRNS. But today, in regards to the Advanced Manufacturing Collaborative, we're going to talk about the vision to reality and beyond. My particular piece will be vision to reality, and then Dr. Green will bring it home. But we're really excited about this innovative approach that the department has done, which is in alignment with administration goals and the community. And it's really a good news story for everyone around. As far as why we created it, what was the spark? And it all began back in 2014. And before I begin, I want to give a shout out to two key people on the DOE-SR team, Mr. Tony Polk, who served as the FPD at the time and director for DOE-SR at the lab, and then Steven Stamper, who kind of brought it home and actually took it across the goal line. So General, I want to thank you too before I get into it. And if you want to know more in detail about how this was actually done, the nuts and bolts, see Tony Polk and Steve Stamper for in-depth details. But particularly, I want to talk about, why we needed AMC. And ultimately, the National Lab needed facilities to grow their expertise and advance DOE's mission. I began my career in 1991 at Savannah River site, and I've been with the lab a long time. And the facilities are been around a long time. As I said, we're celebrating 75 years. So we needed something new to become a part of the team. So the first piece, collaboration. We needed the ability to collaborate with industry off-site. If you've ever been to any nuclear site, you've got to have X, Y, and Z to get through security protocols. We needed the ability to touch base with industry partners to get together, to work together, to be able to develop some of these innovative approaches. Number two, academia. Right now, the facility is located on the University of South Carolina Aiken campus, but it's also in the heart of Aiken, a great place in South Carolina where we're right on the border with Georgia and South Carolina. So there are other universities and other partners that could take advantage as well. And of course, we know we've got the 17 national laboratories where they could come and join in and participate as well. Modern facilities. As I mentioned, I've been there since 1991. We all need some investment in our infrastructure. So we needed a modern facility to engage on the advanced manufacturing initiative for us. We needed the ability to kick off the artificial intelligence and also the material science, basically make the things that we need to do these approaches. So we didn't quite have that, and so AMC fulfilled that. And then finally, innovation. We needed the ability to connect the laboratory with the marketplace. Basically, the things that we come up with, how can we bridge the gap to get them out to folks that can really implement these things to better advance the missions for DOE and also our national security and other missions. So these are the three tenets that went into the initial play of AMC. Next, the partnerships took place, and that's 2015 to 2016. So DOE, Savannah River, I mentioned Tony Polk, who was the FPD and also director at the lab for EM at the time, partnered with SRNL leadership over the years to initiate these concepts. Next, there was a development team initiated, and there's several partners in that, DOE, the National Laboratory. We had components from EM headquarters, EM5, Steve Trishman and team. We had OMB. We had what we call Northwind as our partner who actually designed and built it. And community partners all became a part of this team to help make this happen. We began our early development and engagement with stakeholders. If you've ever been to Savannah River, we've got strong support from our community. And it comes from our investment in partnering with the Citizens Advisory Board, SRNL, Savannah Riverside Community Reuse Organization. Other partners in the area help us be successful. We've got a pro-Savannah Riverside nuclear community, and we're proud of that. So we engage with them early. And then, of course, collaboration with the university, particularly University of South Carolina, Aiken, the industry partners in the coastal Savannah River area, in the state of South Carolina and Georgia, and then the local community leaders. And we've got a large congressional constituent that supports Savannah River. A lot of them work out there. A lot of them have family members that work there. So we definitely had that engagement early on. Moving forward, we were able to attain DOE agreement and approval for the AMC business case. Next, investing in success. So 2016 to 2020, we continued the engagement with OMB. If you do anything, if you build a project, at one point or another, you're going to sit down with OMB. They ensure the president's budget is executed, that it's in line with requirements, and they make some decisions. And so, Steve Trishman, who was our EM5, was definitely engaged with that, Tony Polk and others. Getting the win with OMB was essential, and they were successful. He actually, I know he's retired now, but we definitely made a lot of leeway with him, and those meetings paid dividends in the end. SRNL and DOE concepts evolved to align with EM's needs, and the lab's multi-program growth, because we had a lot of initiatives that were launched at that time. In 2019, the big news story, Congress approved $50 million for AMC. Big deal. Getting the funding approved. That was a lot of work, a lot of collaboration. I will say Senator Lindsey Graham and Congressman Joe Wilson were a big part of that. Getting the approval was tremendous for us. And then we began moving forward. Once again, substantial stakeholder support and collaboration, particularly with the Deputy Secretary for the Department of Energy, University of South Carolina, Aiken, Aiken County Commission for Higher Education and Commitment for the construction of AMC campus at USC Aiken. And, you know, we began the process for the capital construction project, and it went forward. All right, from planning to building. So on April 19th, 2022, we had the groundbreaking. We utilized the Environmental Management Consolidated Business Center, EMCBC. I know Jack is here and his team. We used that process to identify a partner who was Northwind. It's Alaskan Native Corporation, Northwind Construction Services. And they were selected to design and build AMC, particularly with the unique configuration with DOE and University of South Carolina, Aiken. We signed a 47-year no-cost ground lease with USC and with the ACCHE community. Particularly, it's actually 37 years with 2 5-year options that are built into that. And as I mentioned, on the 19th, we had a great groundbreaking. This is a picture of all those who participated. A great time for us. And there were a lot of photos that began from that step going forward. And this was the initial rendition of what it would look like. All right, so construction. So on the top left, you see some of the ground clearing. Top heading is on the top right. A lot of people were able to sign. We're able to attach the flag to it. And that's basically, you know, what top heading is. You put the highest structure on the facility. Bottom left, it started taking shape. Middle, we began a lot of the construction, some of the building of the rooms, components, wiring, all those kind of things went into it. And then the final details there. So this concludes my portion. I'm going to transition to Dr. Green, who's going to bring it home on to the next section.
Thank you, Edwin. I knew I had a tough act to follow coming behind you, but then when you had the bow tie, you know, elevating the fashion, you know, I was really taken aback. I was like, I didn't get the memo. So you look great. So I'll do my best to try to fill in. So thank you for having me here. It's exciting to be here. And you know, Alicia mentioned that she's been, in this role, 5 months or so. And so I'm approaching 9 months. So it's exciting to be here in this forum and really excited to talk about the vision for the AMC and the support that we've gotten from the community and from the environmental office, my environmental management office, and just DOE at large for what we're doing. And so we're one of the 17 Department of Energy national labs, and we're unique is that we're actually, part of a community at the Savannah River site, and we do research that not only supports Savannah River Nuclear Solutions, Savannah River Mission Completion, and the work at the site for environmental cleanup and nuclear deterrence, but we also have a mission that expands for regional and national impact. And so the AMC is a great bridge to help us have more of an impact at the regional and national scale that's more visible and more of a way of connecting us to the community and letting folks know about what we're doing, because as Edwin mentioned, it's not easy to access the site and what I call, being behind the fence. So this gets us outside the fence and helps really be an economic engine for South Carolina and Georgia in our region. So we're really excited about it. So as Edwin mentioned, we had a significant investment, and so we want to make sure that we get a great return on that investment. We've got 63,000 square feet of fantastic research space. Please come check it out. You'll be extremely impressed. It's a great selling point for the laboratory. I was blown away when I saw the amount of flexible space that we had with chemistry space, high bay space. And we've got this partnership with the university there. We've got classroom space, a collaboration space. It's a state-of-the-art facility. And we've also got resilient and forward-looking infrastructure at the facility as well. And one of the things that we did was we benchmarked other facilities. So we visited the manufacturing demonstration facility at Oak Ridge. We visited Clemson, some of their facilities, and a lot of other places. And we tried to pick the best elements that foster collaboration, research, innovation, and also economic development. I was fortunate in my career before joining Savannah River National Lab. I spent 21 years at Oak Ridge National Lab, including some time at Y12. So some of those pictures that were up before, I was like, oh, I remember that, Bill, at Y12. And I also spent 8 years out in Colorado at the National Renewable Energy Lab. And I was fortunate to steward the manufacturing demonstration facility when I was at Oak Ridge, and it's in what they call the Hardin Valley area in West Knoxville. And when those facilities were put out there wasn't much out there. And you know, you look at it now, there's economic development, there's, you know, folks moving there, there's new schools, there's new jobs. It just has totally transformed that part of East Tennessee in that area. And so I think we can do the same thing with the AMC, and that's part of the vision of what we want to do. So as Alicia mentioned, the secretary was gracious enough to visit us. He spent 2 days with us. He spent 1 day visiting the lab and the site, and he met with site leadership, and we had a great discussion with him there. But then we had the pleasure of having the ribbon cutting for the AMC. So we had great support from our local community, and we also had support from our representatives. Senator Graham and also Representative Wilson were there as well. And it was just an amazing day, and it marked the 200th day of the Trump administration and the priorities of the administration for energy dominance. And we've heard about what, the AI push as well, which is the center around there. There was even a headline in the local newspaper talking about, the Silicon Valley of South Carolina. So there's a lot of excitement about what we're doing here. And it was a great day, and we really are excited about that. And I think one of the things that we also can look at as we look at this AI push is security for these facilities that have these AI data centers. That was something that Senator Graham spoke on quite a bit while he was there. So I think there's just tremendous opportunities with AI, not only for supporting nuclear energy, supporting innovation, but also looking at how do you make sure that the data and the facility is secure as well. So a little bit about the AMC vision and what we want to do. And so there's really a base capability that's at the laboratory. So the lab has been around for 75 years. The site has always had a research laboratory. We became a designated DOE national laboratory 21 years ago, and we're the only national lab stewarded by the Environmental Management Office, and we're proud to say that. And we know how to handle nuclear materials. We understand nuclear chemistry, but that also means we understand chemistry and materials. Those are like foundational expertise that we have in the laboratory. And so we use it for separations, processing, all kinds of things. So that's the base foundation, is that materials design and processing knowledge that we have. And so you can use that for environmental technologies, but you can also use it for a lot of other things, right? And so if you can couple that materials and chemistry understanding with additive manufacturing advances that are coming along, with artificial intelligence, we talked about the impact of that, and also automation, then you can look at new solutions in a lot of different spaces. And so one example in the environmental technology space, we just recently received an R&D 100 award with our industry partner, Silica X, where we developed basically a ceramic material that has enhanced properties that are tailored to absorb liquid materials. So it could be used in liquid waste applications at Savannah Riverside, Hanford, and other places with this specifically tailored material, but it could also be used to extract critical materials. It could be used to store hydrocarbons. You can tailor these materials in a lot of different ways using AI and using our understanding of material science to tailor these engineered cellular magmatics to create these ceramic materials and tune them for different applications for environmental technologies and a lot of other ones. So that's something that we're really excited about, an example of the potential. How do we replicate that in this space? Also, in terms of energy infrastructure, there's a Department of Commerce project, SC Nexus. We're a partner on that. It's tremendous opportunity for the region and the state. A lot of partners there. Energy infrastructure is one of the first activities that was part of the SC Nexus grant. And we've got some of the grid infrastructure research is being stewarded and brought in and supported at the AMC. So that's another example. How do we expand that? How do we leverage our expertise in energy infrastructure to keep the lights on, keep it safe, secure, and resilient in that space as well? We also heard earlier about nuclear energy renaissance, right? And so our understanding of nuclear fuels and nuclear materials, how do we use that for fuels that may have been used for defense programs or commercial applications or research applications? How do you take that nuclear fuel and then reprocess it in a way where it can be used for advanced reactors? So that's another opportunity space, and there's a lot of material at the site that could be used to help support and advance activities such as this. And then also our lab, we're the tritium lab. We understand tritium. It's, essential for fusion energy and a lot of other applications as well. And the Office of Science is really invested in the laboratory to help advance fusion energy, work with the commercial sector. We have a project that we lead called FC Fire, where we're looking at how do you optimize the use of tritium in the fusion fuel cycle. And that's another great example of how we can use this facility. It'll be the headquarters of that activity there, and we hope to expand and expand the research footprint and capabilities of the AMC for that. So those are some of the examples of how we're working with the industry, leveraging our expertise in a lot of different areas to have an impact beyond what we're doing at the site. And then I think the last thing I'll mention as well is an example of the impact. There's depending upon numbers, $500 billion, cleanup legacy bill that we're trying to address, and tools like AI and activities like the Manhattan Project too. How can we leverage that to, could we cut it in half, cut it in a quarter? That's hundreds of billions of dollars of savings and efficiency if we can use our understanding of the subsurface. There's data at a lot of these sites. It's the data-rich environment. We understand subsurface science. How do we use that to accelerate the cleanup mission at EM and really achieve the goals that we want to do it safely, securely, and more efficiently? So I think this has tremendous potential in that space as well. And then, strengthening U.S. competitiveness is always important. Workforce development. Edwin mentioned that we're at the University of South Carolina Aiken campus, which is a part of the University of South Carolina system. On our board, Savannah River National Labs board, we have 5 core universities, Georgia Tech, University of South Carolina, and USC Aiken is a part of their system. Clemson, South Carolina State, and University of Georgia. So even though we're on USC Aiken's campus, we're open to partnership with the DOE labs, industry partners, other universities, even beyond these 5. And so I mentioned Silica X, they're a partner we're working closely with. XE Nexus Partners, which has several local and regional partners involved there that can access the facility. And Exemer is one of our fusion partners for the FC Fire activity. It also is a great opportunity to get hands-on experience for students, especially there on the campus. They can come over and take what they learn in the classroom, actually get practical hands-on knowledge, which is key, especially in today's digital age. And then we also are looking at how can we look at entrepreneurial and innovation exchange opportunities through the South Carolina Research Authority. And we want to also, how do we engage with industry more? How do we leverage the DOE investment to then attract private sector investment, then amplify that, have an impact, not only from a mission standpoint, but also from an economic development standpoint as well. So I think that concludes our section. I don't know if we have time for a few questions, but okay, all right. So I will turn it back over to Alicia. Okay, okay, Mark. All right, over to you, sir.
Okay. Good morning. I'm Mark Bollinger, the manager for your WIPP. It's your WIPP. It's all of our WIPP. I want you to eat that, breathe that every day because we need your support. And actually, I feel that support. Sometimes it just came to me, Joe. I feel like the guy in the crowd who jumps out and crowd surfs. Everybody supports WIPP, right? And they support me personally. They support us, and it's been fantastic. I feel it. Feel it in this room. I feel it every day. So the story we're going to tell is about our success and our most recent success this year. So I want you to picture Rocky. I'm told that telling stories is the best way to do this. So this is the story of Rocky. In 2014, WIPP was on the map. We were down and out. And it took a lot of people to get us back to where we are today. And this story we're telling about this year's success is sort of that final fight scene where we finish the job and we get the title back. And I'm gonna thank a lot of people along the way. So Ken and I'll share with you what we accomplished this most recent year. So for those of you who don't know, we are pretty isolated. We isolate the waste in an isolated environment. It's a challenge just to get here today, and it's a challenge for any of you to visit us, as Joel's about ready to find out. But we take only defense waste. We are transitioning to what we call a world-class repository that maximizes the long-term use of the facility as per the Land Withdrawal Act that created WIPP. So we look at the Land Withdrawal Act regularly to find out what Congress intended for us and how to do our business. We move at the speed of safety. That comes from me because a few years ago, I realized that folks were talking about how much should you be in placing at any given time. And I said, we in place as much as we can in place safely. We don't do anything that we can't do safely. Our United Steelworkers are here in the building with us today. They enforce that with us every day. They say, if we can't do it safely, let's take a pause and let's think about it. But our goal is to be there for the generator sites. So our goal is to be uninterrupted defense true waste and placement. We have key capital asset projects that as of this week, we can say have achieved CD4 both this year. Joel's amazing work. He's been here a week and he already got a CD4 done. So he's going to be great for whatever time he's with us. We have a lot of other infrastructure upgrades we need to accomplish. The complex down in the desert is aging. A lot of it was aged when we started, and so we need to keep doing that. Public support, ECA has been absolutely fantastic to us. Our community who are here today, Jack Volpato and others, are amazing in their support for us. And so we need to keep and honor that commitment that the community of Carlsbad made to the government and the WIPP, and be a good partner for them every day. Repository readiness goes to the regulatory nature of what we do. We are highly regulated, and so we need to do everything it takes to be ready to accept waste. And obviously, workforce development is another key for us and a challenge at all times in where we're located. What we've accomplished over the years is amazing. Over 25 years, 26 years now, a lot of shipments. And this year, our number, Ken tells me, is 419. Our goal this year is 425. So we will reach that. Thanks to Joel again. It's going to be a great year. We're going to reach 425 next week before the end of the year. 17.5 million loaded miles without an issue. If you don't think you can transport safely, then you take a lesson from WIPP. You can. Takes a very dedicated team, Mindy and all, do a great job making sure that we keep that very high bar of performance, and we can talk to you more about that. Not only do we say we operate at the speed of safety, we prove it by the data. We had 8 months without a lost time injury, 1.7 million safe work hours, tremendous success in sort of putting our money where our mouth is. Time to you. You got the next one. All right. I want to make sure I transition in the right place. So the Land Withdrawal Act told us exactly how much waste we were allowed to take at WIPP. And that had to be defense waste only, and that we had to have very specific waste acceptance criteria. So if you look at the 25 years of emplacement over those 14,000+ shipments, we still have 55% of the available volume. So I know we'll talk tomorrow about our support to NNSA. We talk regularly about making sure we have plenty of capacity for New Mexico waste. We can finish all the jobs we know about out there in the system and any proposed ones that have been even contemplated in our database, and we still have enough capacity. So we are preparing for the long run, and Ken's going to talk to you about some of the projects we have had recent success in getting ready to be there for you for the long run. I'm still up. You fooled me. Okay, so currently, we are emplacing in panel 8, and you can see the hatched area. If I could do that. Yeah, look at that. The hatched area, that means waste emplaced, right? And so now we've transitioned and we're back here on room 3 now. We just started emplacing. And so that panel has been open about 3 years, and we've been emplacing at a very good pace. We expect the pace will slow down over the next couple of years as we focus on some key infrastructure projects. So that means we have a few years left to work in rooms 3, 2, and 1 in panel 8 before we're closed up there. And then we will have panel 11 ready. It's going to be ready as we call just-in-time mining to allow us to be ready for the next group. So we have an easy sort of decade of regulated, ready-to-go shipments. I want to point out some of the highlights, especially the Lano corrugated metal pipes, a big project for the Lano group to continue the cleanup on the plateau. And we were able to start achieving waste disposal of those corrugated metal pipes from Los Alamos in, I think it was May, June timeframe, well ahead of their schedule to get those pipes headed our way. So we've actually increased the rate from Los Alamos over 100% just over the last few months. So very happy with the progress made there. We also know that the community in Hanford is anxious to start moving waste again. And we have spent a lot of money and energy and time getting ready for that activity. So we are prepared to support. I was just up at Hanford 2 weeks ago, and we expect that we will get that facility back shipping here on schedule. We also just started with shielded container assemblies, which are special containers that allow you to ship RH waste, remote handled waste, in a contact handled manner. And we just had one of the newest containers that has been built and ready for you, shipped by Argonne just this last week, and we emplaced it this week. So SCAs are now available, being manufactured, and can handle a lot of your high-risk RH waste in a contact handled manner. All right, now we're going to talk about infrastructure.
Thanks, Mark. I appreciate that. It's always hard to follow Mark when he speaks. He has such genuine passion and commitment to the WIPP mission, and it just comes out when he speaks. So I love listening to him. When Joel was talking, I was listening, Joel, but I was also watching the video, watching the pictures, and I was seeing all of these buildings go down, and my thought was, they're potential customers for us. So the first strategic priority that Mark mentioned was uninterrupted emplacement of waste. So we've got people that are always ready to receive the waste, but the facility is in fact 3 decades old. So there's a lot of infrastructure needs, and we're going to talk about those a little bit. So the first one was really a combination. It was to get our flow rate up in the underground, and it was 2 projects. Which will improve the reliability of the system. It will ensure worker safety. And there were a number of minor construction projects, not line item projects, that facilitated that, things like tying it into the fire loop. But the first one, you've heard us talk about it before as the safety significant confinement ventilation system. When it was completed, it became the underground ventilation system. We didn't want to say SSCVS for the next 50 years. So that project is now complete and fully operational. It was done about 15 months ahead of schedule and roughly $10 million under budget. We got the CD4 for that back in the week of the Waste Management Conference. It increases the airflow of up to 540,000 CFM in the underground. It will allow us to do concurrent mining operations and waste and placement operations. And all of that air is HEPA filtered before leaving the mine. So the UVS really consists of two major components. One is the salt reduction building, where the air enters that first, goes through demisters and dedusters, and drops the salt out of most of the salt out of the air before it goes into our new filter building. You can see a picture on the right there. That's our new filter building. We have 22 banks of HEPA filters. Each bank has 4 stages, 2 pre-filters, 2 HEPA filters, a total of 72 filters in each bank. So there's roughly 1,600 filters overall to filter all the air. So Mark talked a little bit about uninterrupted operations. And one of the things that we are really proud of is our ability to preserve the mission and literally change the tire while we're driving down the road. So our initial estimate was bringing the UVS online would cause a 3 to 4 month shipping outage, which would be impact to at least 120 shipments. So we set to work with CBFO on how we can shorten that time frame. And there are a number of things that we did, but I've highlighted a few of them. We embedded operators in that project before it was even done with construction, and then they were there all the way through commissioning. And that really gave us a greater understanding of how the equipment would work, how it needed to be maintained. We also made a lot of procedure changes and completed training at risk. So working with Brenda, I think I saw Brenda here. Working with Brenda, we had a good understanding of what the DSA was going to look like, so we felt comfortable doing a lot of the procedure changes and training up front at risk before we got that final approval. That shaved off a lot of time. We also installed a Y on the ventilation, and I'm going to take a minute to talk about a picture on the right. You see coming out of the ground there, that's what we call the Y. There was an elbow that just went straight to the left, went to the current, the old underground ventilation system. And what the plan was initially was when we got to that point, remove that elbow and put an elbow to the new system, which you see up on the top. The alignment of that is a tricky job, and it had a potential for being extended. So what we did during a routine planned outage, we went ahead and put the Y in, and it allowed us to keep using the old system, and we just had a blank flange on the top of that. And then we were able to connect the elbow for that without the pressure of the mine being down. So we were back into operation while we were doing that. So that really saved a lot of time. In the end, the actual impact was only 1 week and 9 shipments. So we were pretty proud of that. The system is currently operating pretty reliably with 2 of our 6 fans. It's given us about 420,000 CFM, and before we brought it online, we were at 170, so significant increase. The utility shaft project works in tandem with the UVS. It allows us to bring a lot of air into the mine, and it will be where we put the new hoist that I'm going to talk about in a minute. But as Mark said, we just got the CD4 endorsement yesterday on that, so we were pretty pleased with that. Similar to SSCVS, it was done about 15 months ahead of schedule and well under budget. So hoisting capability. The 2 projects that I talked about, along with the minor construction projects over the last 10 months or 10 years or so, DOE's invested probably $1 billion into infrastructure at WIPP. The next project on the horizon is hoisting capabilities. And hoisting capabilities will give us 2 new hoists. In that shaft that we just finished will be a new hoist that transports personnel and materials in and out of the mine. Currently, the waste hoist is probably our best hoist mechanically, but probably 85% of its usage is not for waste. It's for personnel and materials. So if we can get all of that off of the waste hoist, we'll extend the life of the waste hoist and have it dedicated just for waste. So that's one hoist that'll be added. And then we'll get a new salt production hoist, which is desperately needed. And maybe the picture is evident to you on the right, but that's the faceplate for our current salt hoist motor. And it's got the date of manufacturer on there, and that's not a misprint. That's 12/18/25. I'll let that sink in a little bit. In 3 months, that hoist motor is going to be 100 years old. So we might have cake. That project, we've currently submitted a CD1 package to DOE. We do expect them to be able to work through approval of that package by the end of the calendar year. And then a couple of other infrastructure improvement projects that were significant to us, and I won't go through all these, but the salt pocket repair. So below the repository level, underneath the salt hoist, is essentially a sump where we dump the salt before skipping it out of the underground. Over the years, the salt squeeze has just completely deformed that superstructure under there. So all of that had to be replaced, and we've just finished that job as well. And another big job for us this past year was the plant chillers. So the waste hoist motor itself generates a lot of heat. We were having repeated problems with our cooling units. So we were losing the waste hoist because the motor was getting too hot. That's really helped us cut down on that and improve reliability. So I think there's just one more slide, and Mark's going to come back up and talk about that.
Okay, so we're off the mat. We've won the fight now. We are now the champions again. We've learned the lessons from 2014. We got off the map. We got the help of everyone in the room. And we've come to where we are today. 2 CD4s on that project. It really closes the book on that. And now we're at the sort of title slide where you thank everybody who helped you along the way. Right now, our team is made up of, obviously, SIMCO has done a great job. Los Alamos has been with us in a local fashion. Sandia is with us locally that helps us on our EPA work. Navarro has been a great technical support services contractor. We also track every shipment that goes throughout the country with Transcom. And CAST is that amazing shipping company that's achieved everything we've done. What's not shown, the steelworkers I mentioned, ECA has been an amazing partner, but the city of Carlsbad and southeast New Mexico have been absolutely amazing to us in achieving what we've achieved. In the immortal words of Rocky, we did it. All right, thank you.
All right, thanks and welcome. And I guess top one. Got it. Thanks. So I know, as you know, Alicia opened up with earlier, about the West Valley demonstration project, and the plant was the first and only commercial fuel reprocessing plant in the United States. You might ask, why are we doing this? This isn't really normally what EM and DOE does. It's not a defense facility, it's a commercial facility. And it creates a pretty unique situation for us. So back in 1962, Nuclear Fuel Services, in the early stages of the nuclear industry, created the first commercial fuel reprocessing plant. And it operated for a number of years and then shut down for some plant upgrades. But some of the politics during the 70s changed, and sentiment to nuclear energy changed, and the facility never resumed operation. So in 1980, the West Valley Demonstration Project Act was passed. And that's why we're here doing this. So basically Congress said the Department of Energy would assist in that cleanup of that site in a way really to do it as a demonstration project. It was, really the start of a lot of the cleanup for the nuclear and commercial nuclear. So in the act, there are a few specific things that we have to do. One was manage the high-level waste by solidification. That was one of the things that was first things that was accomplished. To be honest with you, it was one of the first things that I worked on when I came to the Department of Energy, was the startup of the vitrification facility at West Valley. And that operated from the mid 90s to the early 2000s, and proved that, we could manage the liquid high-level waste that was generated from fuel reprocessing and put it in a form that was safe for disposal. Also, transportation of the material was part of that demonstration act. But then the other key thing is basically the decontamination, dismantlement of those facilities, the tanks and the hardware that are associated with those activities. And that's, what we're here today is one of the very last, one of the very last facilities, but it is the last part of the original processing facilities that were on the site. And that was the main plant process building. And then ultimately we returned the site to the state of New York. So again, it's not owned by the Department of Energy. It's a private facility. It's owned by the state of New York. And it creates, that whole environment there creates probably one of the more complicated structures that we have to deal with in the Department of Energy. From a regulatory standpoint, as well as from all the number of partners that are involved in the site cleanup. Just a lot of complexity gets added to that situation. And so with that, we had to, really work together with the contractor, and really contracting is also another key factor there. The original contract was awarded to CH2M Hill BWXT in the 2011 timeframe as a completion contract. So they were under contract to finish, the main plant demolition is one of their last activities. And the way we do our contracting, then we had to get a new contract in place. So we definitely did not want to go through a transition right in the middle of the demolition of one of the most, complicated activities that the department was taking on. So we had to be very strategic in how we awarded that contract, manage the transition without interrupting, the demolition progress, safety, everything going on with that. And so Jason Casper is here. He's thankfully, he's had a role in both. He's basically had the same role at the end with CH2M Hill BWXT. He also has the same role right now with the new contractor, WVCA. So with that, like I said, we partnered with DOE, partnered with the contractor, really completed, the readiness assessment process, took a lot of attention. We reduced legacy waste and risks, and in the end, completed the demolition 30 days ahead of schedule and $40 million under budget. But along the way, like I said, we did the approach with open air demo and had a lot of challenges at the start. Bottom line, everybody remembers COVID-19. We were just getting our critical decisions to get started, get in the field, get started. We got them approved a little bit in advance because we saw that the pandemic was ending. Some of the restrictions were being released. And then the administration changed, and in 2022, we basically had additional restrictions that delayed us getting in the field a little bit. So that had a little bit of impacts on our schedule, or they would have finished even further, ahead of schedule. But it caused, in the end, it probably caused a 6-month delay in really getting in the field and getting things ramped up. But we also had to deal with a lot of the issues with COVID-19 in the very close quarters of the work. In order to do the open air demo safely, we had to reduce the source term. That's a lot of, very close activities. Had some, COVID issues to deal with there besides the work controls. Took a few pauses back to make sure that we could handle those activities safely and keep the workforce, fully engaged. And really that does tie to, the biggest issue is the decontamination of the product purification cell. That was a highly contaminated area. The plant, it was confined space. And again, those activities went a little bit slower at the start in order for us to execute those safely. But in the end, that ate into a little bit of our schedule contingency. But, the success that we, saw at the start of the project was able to be, really sustained and continue throughout the project. So we also had issues with the dust suppression and water management. There's, critical things that take place there. Obviously, the open air demo aspect was important for us to control the dust. The site is a very small site, has the public within a few hundred meters. So the partnership that we dealt with the public was very critical. And obviously the dust suppression was part of that. Jason could go into some of the technical matters, but really they were using something, I guess, technical terms, gorilla snot, which was basically sprayed through some snowmaking machines in order to, suppress the dust. And then we invested some money in the water management, because then you gotta be able to control all that water that's going off the site. So we created some water treatment system. So as a lesson learned from other demos on the site, so we were able to really control the water and be able to release it and not have any delays associated with those activities. The weather in Buffalo, obviously cold. So, freeze protection was also another critical element of the activity. And then dealing with the public sentiment. I mean, that was one where there was a lot of activity up front, in the partnership with the community, really dealing with the Citizens Task Force, some of the local neighbors, as well as the workforce, and developing some of the controls that we would have to implement to really give the confidence to the community that we could do the open air demolition safely. And some of that involved almost near real-time air monitoring results posted that the community would be able to see on the website, so they could really see on a daily basis the progress being made, and that the fact that it continued to be safe in the area. And again, like I mentioned, like I said, the site's small. A lot of DOE sites you might look at, we talk about square miles. Well, there it's just a few hundred acres. With a public road right on the edge of the site and houses on the other side of the road. So a few hundred meters, separating the public from this activity. And we did, equipment availability is another thing, but we used contingency to make sure that we had some spare equipment, reach equipment, heavy equipment. Basically, the cost benefit analysis would show it was more effective to have those spares than really lose a day of work. So we definitely, invest a little bit of contingency, make sure that the equipment remained available to continue the execution throughout the whole process. All right, and let's see, I think that is it on my side.
All right, Jack alluded to this. If you look at the site, the main process plant building, and how small this site is relative to the public access, that public road is commonly traveled. There's a lot of traffic that goes along that. So it really drove to risk reduction and making sure that our approach was very controlled to prevent any spread of contamination that was significant, which, as many of you know, is very difficult in an open air demolition forum for a complicated, radiologically contaminated facility. We used a lot of different tools to set up that planning, to really lay out the approach. This was one of our key tools. We used 3D modeling. The picture on the left is all of the yellow structure that we actually removed. And the picture on the right, obviously, is what was left after we were done. That picture on the left, we were able to pull small pieces of the wall out at a time and use that as part of our briefing with our workforce. So they understood exactly what we were going after down to the day. I mean, maybe a 10-foot by 10-foot section that we were able to remove in a day because we were controlling the amount of material that we could attack at any one particular time. So very effective tool to make sure that real time we were able to successfully complete the work. There are a million things that we talked about as we were going into the planning phase. A lot of lessons learned that we were able to pull from other sites, a lot of new thoughts because we were such a small area. The demolition sequence and rates was one of our critical aspects for doing demolition. We needed to use deliberate speed, and Mark mentioned speed of safety. It's the same concept. We really had to approach the work slow and steady, with the intent that as we got better, we got more efficient and we got more effective at getting the work done. And it worked out just as we'd anticipated, a very effective approach to the work. The sequential approach, we could only bring certain areas that were higher contamination. We could only bring down a small portion of that during a particular day. We didn't stockpile waste. That was a little bit different than what I've experienced before in demolition work scope. We would take a specific portion of the building down, it would hit the ground, and then we would not restart demolition until we had completely repackaged that, typically within the same day. Occasionally that would go over a little bit into the following day, but we didn't restart demolition until we'd made it all the way through the repackaging. And then Jack mentioned the equipment. We had not only contingency, but MR applied to making sure that we always had equipment there. Down days are not good days for a lot of reasons. One, it's way more cost effective to have the equipment there, but as they say, idle hands. We wanted to make sure that we had people continually working, and it worked out very well. We hit that spot on. Water management in the Buffalo area, a little bit of snow occasionally. My first experience was 8 feet in a day. So yeah, a little bit of snow. But as that snow melts off, you have to be able to manage the water. It really wasn't the dust suppression that was the issue. It was all of the natural rainfall and snowfall that we really had to have a good process in place to manage that water volume, to ensure that we weren't having any spreads of contamination because of the precipitation. And the way that we established that is we set up a batched system. So we were able to pull water out regularly, put it into batches, sample, characterize, and then disposition it. We actually built a system that was able to process 2 100-year floods in a 2-week period. So we had plenty of contingency in place to make sure that we were always able to manage ahead, that it wasn't going to get ahead of us. Dust suppression, contaminated facilities. It is all about dust suppression. I've got some great pictures and a couple of videos here that we'll see in a minute, but managing the dust suppression, we were able to see real time on our environmental monitoring if our dust suppression was off at all. You could see small spikes starting to build into our radiological real-time monitoring. So we would adjust and make real-time changes. So it was a great partnering between our workforce, the craft on the floor, our RADCON organization, and the management team all working together to pull the whole thing together. And of course, a little bit of freeze protection because it does get a little cold there too with the 8 feet of snow. I mentioned the radiological controls, ECAMs. That was real-time monitoring. We had a local ring that was right around the footprint of doing demolition, and we really would watch as we were doing demolition. We could see small spikes. If the dust was getting past our dust suppression, we could see very small rises that came in. Actually, the biggest issue that we had was some of the Canadian fires a couple of years ago. We had big issues with radon buildup on a lot of our detectors. And that was one of the things that kept us a little bit slower at the beginning, is because we were fighting our way through those radon influxes. But the system was great at keeping us focused in the right area so we didn't have spreads of contamination. I already mentioned the stockpiling. We did really good at minimizing that accumulation, packaged as soon as we had it, really on a day-to-day basis. And none of it could have been accomplished, obviously, without significant work planning on the front end. We use something called a protected assumption. Our protected assumptions were those things that we wanted to make sure nobody made changes to. They were protected assumptions of how we approach the work. An example might be wind speeds. So if we had wind speeds within certain ranges, and you would think that it's only high, but it was actually low as well. If we were in those ranges, we would stop, make sure everything was locked down so that we could move forward. We had certain portions of the building that we could only bring down in very limited portions. So those were protected so that we couldn't make changes without going back through pretty rigorous engineering and environmental checks to make sure we were not going to step outside of what our controls needed to be. All of the work controls that we generated, we did have a rigorous internal review. We also partnered with our customer who reviewed our work control, understanding a lot of the outside influences as well to make sure that we were all on the same page for being able to move forward with the work day to day. And the whole process worked very well. They were always spot on. We were able to get them their reviews very quickly, and they were able to turn them around very quickly. So it worked well. So all of the scope, all of the planning on the front end really drove what I will simply categorize as an amazing accomplishment at the end. This is the first date, first bite, September 21, 2022, pulling down a fairly low risk piece, high risk or a high reach piece of equipment with a grapple on the end pulling pieces down. As Jack mentioned, we did have, that was our only long reach, but we had other pieces of equipment that were similar that we could use from a contingency standpoint. So we always made sure that we were able to cover back if we had downtime on equipment, which you always do. This is the before and after, almost after, I'll say. The picture on the left being the main plant facility. The biggest portion to the right on the left there is what is called the fuel receiving facility. That's the last structure that still stands. It was not part of the main plant, and there was some thought that we may be able to use that on the future approach to demolition. On the right side, you can see that fuel receiving facility a little bit more to the back or top of the picture. The front portion, all the brown, that is where we were bringing in soil, really for a temporary cover so that we could shed water real time as we put together the plan for the next phase of scope. The above grade portion being the 1A portion of the demolition, and the below grade portion as we move in as the new contractor WVCA is really the 1B scope. We'll talk a bit more here. This was the last piece of the major demolition. Jack mentioned this as well, the product purification cell, the PPC. It was a relatively small room. Even I could stand in that cell and reach out and almost touch both walls, the short direction, long direction, more like 15 feet in length. But very tall, four stories tall. This was highly contaminated with everything that you can think of. And our initial approach, without doing any decon, this was going to be a very, very, very difficult demolition. We were able to go in and do some nitrocision work, decon the walls so that we could approach it from a demolition standpoint. The approach was, again, very strategic in that the first thing we did was we started at the bottom. Surprisingly, we punched a hole at the very bottom of the wall. And then as we did demolition, we were knocking the debris into a controlled center of the PPC, and then we would remove that debris out of the bottom and package that every day so that we kept really good control of the contamination. In fact, we had very little that we even saw on our perimeter sampling associated with the PPC. Picture on the right is a great picture. You can see the demolition piece of equipment, obviously hammering on some of the concrete, but the particularly entertaining is the blue long arm pieces of equipment that are there. They actually have a snow generator head. We used it just for misting our water that was developed right there in the area in New York, but we had up to 5 of those running at any one time to knock down all of the dust to make sure that we had really, really refined control as we were doing the demolition. So that worked out great. So video of the demolition itself, compacting 2.5 years in 2 minutes looks pretty clunky, but a couple of things to keep an eye on. One, just the weather changes. It's pretty exciting to watch just that. Our general approach, if I can get that to start. Our general approach was to work from the west, which is we're looking towards the east. We moved pretty much through the middle of the facility. The south portion of the facility to the right is where the PPC was, heavily contaminated, and the northern part was relatively clean. So we could move back and forth depending on what we needed to do day-to-day demolition. If we completed our the maximum amount of MAR that we could address at any one time, we were able to use the north portion of the facility to be able to establish some additional demolition. We moved through the process mechanical cell, and the chemical processing cell is really the big structures in the middle, walls that were anywhere from 3 feet to 10 feet thick. That's what they're working on right there. It takes a significant amount of time working through that 10-foot portion. Liners inside of in the cells themselves. So the concrete was not in too bad a shape, but those liners were heavily contaminated, and did involve a lot of equipment operators, spectacular workforce, making sure that they were collecting those liners appropriately and in small enough sections that we were limiting the MAR. It's a little bit to see, but in the forefront there was the off-gas cell, the last wall that we brought down prior to going to the PPC. That off-gas cell is the source for all the below-grade contamination, and so it was also a hot portion of the demolition. Again, came down just as we had hoped. Ended with not just a soil cover, but a temporary geomembrane as we do the planning in preparation for the next phase of scope. So it gives us a little bit of time to work forward on the next phase. Can't say enough about the workforce themselves. It's a spectacular group, many of them that have been on site for as long as 50 years. Some of our engineering staff, very dedicated to where we were at and moving this whole thing forward, down to our still workers, our craft, doing the work in the field, the integration between the teams as they pulled it all together. It was a really exceptional workforce. Public engagement. Jack mentioned not only were we close to the public, but there's a lot of different groups that we dealt with. Everything from Seneca Nations to people that live less than a mile away to our regulators, NYSERDA, NYSDEC. There's a lot of different groups, stakeholders that were involved with us. We were able to use some of the animations that we did on the front end. This is the approach to general demolition, where we could walk through with those groups and show them what it was going to look like, as well as what our environmental monitoring was going to be, and that we intended to be completely open and honest. We were going to share that real time, give them as much exposure to what was going on. Those were pretty energetic, especially the beginning of those public meetings, but at the very end of those, I believe that led us to the point of really being able to execute and everybody being comfortable with where we were at. I mentioned the air and water sampling. We actually did a citizen task force every quarter where we presented the information, shared exactly what we saw at our external survey points. So everybody got to see what we were at, and that we were staying well within the levels that we had predicted under our air modeling. So it went very well. And the town hall meetings that we did on the front end were probably some of the biggest successes, in that everybody knew what was coming. There were no surprises. Everybody was on the right page to make sure that we were going to be delivering the work scope safely and compliantly. The protected assumptions were another really big one for us, making sure that we didn't make changes to the work control willy-nilly. We really needed to make sure that we protected the specific assumptions that we had for how we were going to approach the work. And if we did need to make a change, which you always do, we really wanted to make sure that it was a true step back. We thought about it. What are the implications of making that change? Just general wind currents around building structures could drive major changes in what you actually see for spread of contamination. So we really looked at those in detail. The radiological monitoring being real time with our control room, I mentioned at the very beginning, we were making minute-to-minute changes with our dust suppression systems because we could see the radiological at a very, very, very low level, the contamination fluctuations. Okay, we need to move to the right, we need to move to the left. Very, very integrated team that worked out well. This demolition sequence, which really ran into our protected assumptions. I mentioned the nitrocism, the very aggressive decontamination that we did inside of the PPC. That really got us to the point that we were able to do that open air demo. Without some of that aggressive decon, it would have probably been more along the lines of diamond wire, large hoisting and rigging evolution. So it really got us to the point that it was a much safer demolition. And I've heard a few people talk about the stop work, step back. We definitely encouraged it and we used it a lot. Our workforce definitely, if there was something that didn't look, feel, smell, perceive right, they would stop. We'd take, the 2 seconds, the 2 minutes, the 2 days, whatever it took to get us into the right spot. And it definitely precluded us from having major issues. They did a great job. And then obviously the strong partnering with DOE to get us to that point. And it was, we started in the planning phase and it went all the way through the execution phase of demolition. Both of us on the same page, which really led to that end milestone that Jack mentioned, 40 million under and 3 months ahead. So great place to be able to say that we ended the work. Great project that really set us up for being able to move into this next phase of work. What a great place to be starting from. A lot of success on that above grade portion now as the West Valley Cleanup Alliance takes over and starts to focus on the below grade portion of demolition. WVCA assumed the position or assumed the contract on June 24. Jack mentioned I've got a little bit on both sides. So I was there for the CHPWV contract as the general manager, now following on with the program manager with a great group of people that have joined me to be able to deliver the work scope. The biggest piece of the follow-on work scope is really the demolition of the remaining below grade structure. Surprisingly, if any of you've seen or any of you had the opportunity to see the above grade portion of demolition, the below grade structure, the concrete and steel below grade is actually a little bit bigger than what we had above grade. So it's a massive demolition below grade to the tune of about 1 million cubic feet of concrete that we're going to deal with. The soil that we have to deal with that is around that is going to be in the neighborhood of 3 to 6 million cubic feet around that facility. So it is a huge evolution that we're moving towards as we go below grade. And that's only the first step. There's a whole nother soil remediation contamination piece that's another 6 million cubic feet. So it's a big evolution below grade. We're also very focused on the legacy waste. There is still greater than Class C like waste on site. And as mentioned, the position has been that we are non-defense. And so what do we do with that waste? So we've spent a lot of time approaching it in different, looking at different opportunities on how we might be able to disposition that waste. That's one of the big focuses under the new contract. And the last, and certainly not the least, there is a tank farm with 4 tanks, 3 of those that are essentially clean. The 4th tank that does have a pretty good sludge hill in it that we have to remove. The final end state for the tank farm hasn't been decided. That'll be under the next phase, phase 2. But our scope does include getting that sludge out of the tank that still remains. And that is going to be a challenge for us and for the site to be able to accomplish. And I think with that, I'm done.
Thank you, Jack and Jason. This is such a great way to start off the workshop, to hear about the big things EM can get done for the American people through the support of the Trump administration. We're not just driving down environmental risks, as important as that is, but these projects help show how EM is enabling DOE's important energy, security, and innovation missions for the future of our country. Like Joel said, we're not done yet. I'm proud to have the chance to help drive this program forward, and I hope you all are as well. Please join me in thanking all of our panelists. Thanks.